Hello and welcome once again to episode 59 of Code Completion. We are a group of iOS developers and educators hoping to share what we love most about development, Apple technology, and completing your code. My name is Dimitri and I'll be your host once again for this episode, and I'm joined today by my fellow completionist, Spencer.
Hey there.
So before we get into our main topic, it's time for our Indie App Spotlight. Today we are checking out Morpho by Jeremy and Casey, an iPhone, iPad, Apple Watch, and Mac app giving you access to quick conversions. Morpho makes it easy to convert between units with a focus on travel and speed. Convert between 214 units and 170 currencies and get details for 256 countries and regions, including my favorite, plug types. And even add your most used conversions to your home screen. Morpho is free to try and costs either 50 cents a month or $14.99 as a one-time purchase. So please be sure to support Jeremy and Casey by trying it out today. And if you are an indie app developer, we want to hear from you. We basically have no one else on our backlog. So we have a few people with multiple apps that we'll get to. But if you have an indie app, please let us know. We will be more than happy to spotlight it in the future. So ever since last week, I've been spending a lot of time watching videos on how they used to write games back for the SNES and stuff like that. And it's super fascinating. But a topic that came up quite a bit was abstraction. So I figured what better topic to talk about since there's quite a few different ways that abstraction can come into writing code. So Spencer, what's your favorite way of abstracting things?
I don't know if I have a favorite, but one that, we'll often use is on the daily is, for example, UIKit, right? Or any real Apple or any framework. I mean, you could think of as sort of an abstraction of code, right? Where we, I mean, ultimately it's getting compiled down to zeros and ones. It's going, from assembly to zeros and ones, and we get to assembly through all of these frameworks that we're using. And so it's just, we're kind of abstracting things to make it easier for ourselves instead of writing zeros and ones ourselves. Mm-hmm. So whether that comes in the form of our own code, just making it easier to reason about whatever you've got going on. Maybe you've got some complicated network call to go fetch some data from an API or something. You just say, go fetch this data. And that's maybe one function. That's, I think, abstracting out what you need so that when you need to go fetch that code or go fetch that JSON or whatever, all you need to do is call the function, and it's sort of been abstracted out, and you're kind of hiding that complexity behind the function call.
Mm-hmm. If and that makes sense. Yeah, it totally does. And I'm so glad you brought up assembly and all that, because you did not take any sort of courses in computer science, correct?
No.
And neither did I. And I don't think a lot of people, especially those who are listening to our podcast, necessarily did have such a focused background on how computers work. And one super neat thing that I've been learning about lately is how all of that kind of works together. And I say lately, it's for the past 2 years I've been learning about it. But it feels lately. That's how fast things are going now. And there's a YouTube channel by Ben Eater, and he basically goes through these layers of abstraction all the way down. Hey, let's build a computer from nothing. And then at a certain point, some part gets impractical. So it's okay, we're not going to build the CPU from nothing anymore. We're going to just use this chip, but it's exactly what we just saw. So if you want to build the CPU from scratch with all the microcode and all that, you can go watch that, and we can build it from scratch with wires and diodes and things like that. And that would totally, that's totally possible. But at a certain point, it becomes impractical. In a modern day CPU, there's millions upon billions, I should say, not millions, billions of transistors. There's no way a single person could ever hope to place a billion transistors on anything. So right. It's only by abstracting, okay, we can put 5 transistors into a group like this, and it makes this gate array. And then we can just use that gate array as an abstraction, and then build that up, and now we have an addition unit, and that's an abstraction. And then you can multiply those units, and you can get a bigger and bigger idea. But all the way down, it's just electrons moving around on a wire. And like when you think about assembly, you are quite literally just configuring a circuit every single time you have a line of assembly. And we don't really think about code that way.
No.
Nor should we need to, right? We are free to think of it from a very high level with objects and how they interact with each other over networks. And we don't think about the details of any of that. And that's what abstraction gives us. It gives us the ability to escape that, right?
Yeah, absolutely. It's funny that you mentioned, that we just had to abstract things out at some point. A couple days ago, I was watching a video by his name's Steve Mould on YouTube, and he makes what he calls a water computer, which is just a way to add two numbers together, but it's using these syringes and these sort of, funnels that use, I can't remember exactly.
Well, siphons, right?
Yeah, the greedy something siphon. Anyway, it's really cool, and it's, just put on some foam core with these things, and you're able to put in binary numbers, and it will spit out, whatever your addition is. So 9 plus 6 or whatever is 15. And he's like, and he says something that it kind of reminded me of this. He says, none of this is magic. Computers aren't magic. It's just zeros and ones. And this is like the most basic distilled form of computing. And then from there, like you mentioned, we had to abstract things out. And so now you've got assembly, and we kind of just go up and up to the point where you're right. We don't need to worry about it. And that's kind of the nice part, where that's been taken care of, whether it's down to assembly, down to iOS, down to having pre-made buttons or whatever it is. We can kind of focus on not having to build that for every single application or every single use case, but we've kind of got this nice foundation, ironically, to use. And so we can then dive in a little bit quicker. Dimitri's also been sharing those SNES development videos with me, and I've watched a few of them. They are absolutely fascinating, and kind of goes along with what we were talking about in a previous episode with working within limitations and figuring out, how do you store an entire game on, what was it, like 16 kilobytes of memory or something like that? Absolutely tiny amounts. And even they were just talking about even storing the color data for like a single sprite is huge in comparison to the amount of memory they have, storage they have. And so how they work around that is really cool. And it kind of goes step by step in how they get into optimizing that code and making sure that you can fit an entire game on it, which is, not anything that we have to think about. We have hard drives that are, in our phones that can be up to 1 terabyte now. So that's not even in my realm of thinking when I'm working on an app.
Mm-hmm. Yeah, they truly did need to be exceptionally creative in how they implemented any of it, because like there was just no processing power nor space. The processor was fast enough to think faster than the scan line on a CRT. That was like its bare minimum. And that's all you had working for you at that point. Like you could not, like some examples from these videos that I found fascinating, where you cannot update the screen if the scan line is like writing pixels, because that is like an active buffer that needs to be hooked up electronically to the display. So it's like you cannot write to it. It's just not possible, because there's like it's disconnected from you. So like you have no chance. But thankfully, the way CRTs are made, there's actually some time where the electron beam is actually off screen, and it's like getting back to like the next line. And while it's off, you can do all sorts of stuff, and you have a nice little pocket of time where you can go ahead and be creative on how you're rearranging your buffers or adding movement and stuff like that. And that's how you had a lot of the effects, like in Earthbound, where there's like this crazy background effects going on. It's like, but I don't understand. It's supposed to be a static background. That's all the hardware was capable of. It's like, well, it turns out between every line, you can go ahead and modify things ever so slightly. And that will give you a crazy psychedelic effect as a result of that. And I think it's really cool how, because of those limitations, they had to be really creative as far as like how something could work. Whereas nowadays, like everything is possible. Like in terms of like what they were doing back then, and it's a lot harder to land on happy accidents that way, right?
Yeah, definitely. And something kind of that I've just been thinking about with abstraction is, I don't know if it's, I mean, I think there is a fine line and there is a use case for abstractions, right? It's not like it's always the answer to abstract things out more and more. I mean, it doesn't really make sense to maybe abstract your own code out and then abstract that abstraction and keep going like that. I mean, like the easiest thing I can think of is like, what is it called? Alamo Fire or AF networking or whatever it is, right? Like it's a wrapper around an it's a wrapper or abstraction of URL session essentially. I think it has some extra features, but more or less it's just abstracting out what Apple has done. And some people use that religiously, and that's great, but at the same time, I don't know if it's like a crucial, necessary abstraction, if that makes sense.
Yeah, like URL session is the abstraction in a way.
Exactly. Yes.
Like you should be, instead of abstracting URL session into a generic networking library, you should be tempted instead to abstract it into a very focused networking library that's just for your needs and your use case. And that's the only thing that uses the URL session, and everything else in your app uses your network manager or whatever you want to call it. But I love that you brought that up, because I think AF networking started off as an abstraction of NS-URL connection, which was a much different API that did require a lot of boilerplate code in order to like do things that were super common. And URL session doesn't really have that problem, I would say. And some people came to rely on AF networking as a result, and therefore they had to kind of change the underpinnings of it, and then like they could continue using that same API. But it's almost better to never had to need to rely on it, if that makes any sense.
Yeah, no, I agree. So I think it seems like, I mean, these abstractions, we could just really almost, in some ways, draw a parallel to just third-party libraries in general, where maybe sometimes it's like, it's something that's completely out of your wheelhouse, right? You just absolutely cannot, you can't write that or whatever. But at the same time, I think there are some that are just like more of a convenience abstraction more than a necessity. So while I would say that we are in our own apps, we'll maybe write a helper function to do some commonly performed task. That's like fine abstraction. That's what you have to do. If you're going to use something more than once, then write a function for it. And that's a great way to obfuscate the code, and you're not having to repeat yourself. But at the same time, I think it's not always the answer to have an abstraction in like a very general abstract way of saying, right? It's not like the one solution. And there's overhead as well.
I definitely think the benefit to abstractions come when you can add value, right? Just think of the networking stack, because that's an abstraction on top of an abstraction on top of an abstraction itself. Like you have your Ethernet cable, which has ones and zeros on it, but that is not an HTTP connection. That is an Ethernet frame that is being transmitted over 4 twisted pairs back and forth between 2 computers. Then on top of that, you have TCP, and then on top of that, you have, or actually I skipped the IP protocol, the Internet Protocol. We like skipped that one completely. But you have that one, then you have TCP, and then you have HTTP on top of that. So each level of that is kind of framed and negotiated and transmitted in a slightly different way with different trade-offs. And some people are tempted, hey, I don't want TCP, I want faster, so I'm going to use UDP. But TCP gives you a bunch of stuff that you get for free if you use it. Whereas once you start using UDP, then everything seems faster, but you're also like throwing a bunch of noise onto the network that no one else can do anything about. Whereas with TCP, it will like say, hey, slow down. Like you cannot transmit stuff this fast. And that's why it's not as fast. Even though you can get more consistent speeds out of it, because if you listen to what it's telling you, you can basically do what you need to do. So really, anytime you want to abstract something, really think about the value you are adding more than anything. Because at this point, AF networking doesn't add so much value over URL session in a way or a capacity that you can't do yourself and make more specialized for your app, right? And I feel bad for picking on AF networking. But it's an excellent example in this day and age because it's not super necessary anymore.
And it's like fairly popular as well. I mean, I've seen both job postings and, just people on Twitter and stuff talk about using AF networking. So it's not like it's this random third-party library that is specialized. It's networking. It's something that almost everyone is going to do in their app.
Yeah. And something that I do kind of like, I say this ironically because I am planning on writing a tutorial series about like a generic network wrapper. But it does things in a very different way. So you'll have to wait for that surprise when I eventually write it out. Like I have 3 projects that I'm kind of using this kind of pattern on. And I'm quite happy with it, but I'm still evolving it. So that will have to wait. And at that point you can tell me, but Dimitri, didn't you say like it's kind of pointless to add stuff like this? So like that aside, there are other like excellent opportunities to go ahead and abstract code. Namely, if you're stuck using another SDK or hardware specific code in any way, you want to write an abstraction layer that is kind of abstract. It is not tightly coupled to what you are trying to do. And that's very important because as hardware kind of gets swapped in and out, as requirements change, you can have something that the rest of your app is kind of relying on in a stable way and then just go and mess around with one component safely without kind of needing to impact anything else. So one great example of this from my own projects in the past was we were writing some code that would interact with video recorders. So basically you have a video feed coming in and you wanted to capture or put a video buffer back onto it. And we were working with 2 different hardware manufacturers to kind of interface with their boxes over Thunderbolt or USB at the time. And neither of their SDKs or libraries worked in the same way. So our code could have ended up very chaotic as a result. And needless to say, if we needed to ever add a third, that would have been like a horrible situation to be in. So anytime you need to deal with one external SDK, or in fact any external code that is not your own, I would go ahead and say write an abstraction over it, like document that very well, because otherwise it's not really adding value, right? So write something that can go ahead and hide away the complexity of that code, so that way you or anyone else in the future doesn't necessarily need to interact with that code. But if they do need to interact with it, it's very isolated, and it's not being touched by 100 different lines all at the same time.
So we do a similar thing on LumaFusion where we've got kind of a general, I think we're just using a protocol that is, for like sources to import or export content from, and we just say like, hey, here are the methods that you need to essentially conform to load an object or fetch an object or whatever it may be. And so anything like Dropbox or Google Drive or whatever that we want to connect to, we just kind of adopt that protocol in a new class and say, for Google Drive, this is the specific calls that we need to do to fetch that content or whatever. So definitely makes it a lot easier because, like you said, then you only have one point at which the rest of the app is kind of calling that code, and it says load this object. Doesn't really matter where it's from. It'll just make sure that if it's from Google Drive, it'll call that code or whatever. So makes it super simple. So definitely, yeah, just essentially like yours. Instead of hardware, it's just, content sources.
And another great use of that is anytime you need to mock data in, if you have an abstraction layer where all of your code uses your abstraction layer, then your tests can plug in a different component. So back to URL session, for instance, you might want to have code that like makes network requests, but that's not super optimal during tests when you want to see if other behavior like behaves properly. And if you have an abstraction over a URL session, then if you write it in such a way where you can plug in a mocking object for like a given request, that's an excellent use of abstraction where now your tests can go ahead and load completely fake data either instantly or with a delay of your choosing. And you can see if everything behaves appropriately in all sorts of different conditions, if there's an error or if there's a timeout and so on and so forth.
Right. Yeah, that makes sense. And we did that at Lambda School, and it ended up being really cool where, yeah, you don't want to maybe wait for that network call. You could just plug in, like you could grab the actual data that's going to get sent or received from an API and then just kind of hard code that into your mocking or however you want to do it. But definitely can save time on testing for sure. And you don't want that in your tests. You don't want an external source of potential errors when all your tests should be doing is testing your own code instead of also testing. What if their server goes down, then your tests don't work, and you're like, well, then you have to figure that out, and that could just be a whole mess in and of itself.
Mm-hmm. And that's not to say you don't necessarily want tests that do hit the outside world. You just don't want failing tests that are specific to your code. Like for instance, because in an much older project, our backend was not writing tests. I wrote tests on my side that checked every endpoint, and that's what we had because it was easy for me to do it, and they didn't have any tooling to do it on their end. So, like sometimes you use the tools that you have. It's sometimes okay to write tests that do point to the outside, especially if that's like something your team controls, and it can be a great use to see if things are still compatible and stuff like that. But at the same time, like write tests that are a bit disconnected from that as well, so you have more full control over it. One great example is StoreKit testing. I don't know if you've ever had a chance to play with it,
No.
but if you have an app within app purchases, you immediately like dread this point in app development because you can't really control every situation, and it's like once you buy the thing, then it's tied to that Apple ID, and you need to like go in and figure out how to delete it or make a new account, and it's a big mess. But with the StoreKit testing, you have full control over every situation, and you can just with a few clicks like configure it the way you want it to be configured, and that is super powerful when it comes to testing. And the same applies to this. Another aspects, because I know not everyone is super into testing. I'm personally not when it comes to UIs, but something I do enjoy when I'm working with UIs is SwiftUI previews. And if you can plug in a mocked network instance at that point, then you can control exactly what your preview is supposed to show, which means that you can show all the different situations all at once. Here's a little bit of data, here's a lot of bit of data, here's no data returned, here's a failure of no data, here's a timeout, here's what it looks like when it's loading. You can see all 5 of those different situations all at once if you design your previews well, and that is super powerful.
Yeah, that's super cool. I didn't even think about kind of connecting it to SwiftUI, but that sounds like a really, really nice way to I guess without hard coding in those previews, you just say, hey, go to this network, this mock network helper and do it that way. That's super cool. Okay, so let me ask. So we've kind of said abstraction is good, abstraction is bad, but like when do we decide to abstract something? Is it like, at what point in the development process, I suppose, do we abstract things?
You get your magic 8 cube out and you give it a shake.
That sounds about right.
So it's hard to know like when it's good and when it's bad. Um, in a way, like premature abstraction is actually the root of all evil. I know we said that premature optimization is not, because we should be optimizing more. But if you abstract too much, then you end up with code that is very hard to reason about, because then out of nowhere you end up with clean and viper and all those neat
Right.
acronyms. And that's great when you as a developer only ever need to touch one portion of an app and never anywhere else, but it's very hard to keep the entire thing in your head at that point. So abstractions should be used when, as I said, they add value. There's no point to kind of taking a one line kind of functionality, like a lowercase, and make a function to make a string lowercase. Like you are not adding any value there. And in fact, if that is only being used as one like part of your code, that's fine. But if it's now being used by like 20 different parts of code, and you make one change in there because you're like, hey, I didn't want the string to be lowercase anymore. I want it to be uppercase. So you go inside your lowercase function, you say dot uppercase. Now that made it uppercase in the entire app. And that can have lots of downstream consequences that you are unaware of, because now you have lots of dependencies that rely on it. So that is something that you just need to think about when you're designing your API that you're using internally, and that's going to indicate whether you want to abstract something or not. I personally am not a fan of single-use functions, meaning they are only being used in one place in code. In the past, this would be a foolish thing to do, because the compiler would be like, oh, let's make a subroutine out of this. And then that just makes your code slower out of nowhere. Swift is a bit more more intelligent in that regard. It will detect that you're only using it in one spot, and it'll be like, okay, let me go ahead and inline this, because that's going to make it much faster as a result. So there's no downside to this anymore. But again, it makes it easier to misuse the code in the future, and it makes it more fragile in that way. There's no limitation on like how big a file should be or how wide it should be. Like I remember reading something a bit crazy, that the 80 character thing like is based on punch cards. But it's based on punch cards because Nazis were propagating it. So that's like something that we don't really think about. But that's a thing that's apparently true. So like, there's no reason to have these constraints anymore in terms of, I know I said before, like limitations are good. In terms of like reading your code, there's no necessary need to have constraints in terms of how big your file is or where your stuff is. Like you can just search your project. If you aren't kind of navigating things easily, you can command click on stuff to just jump immediately to where you want to jump. So like put your code where it makes sense from a reading point of view. If someone's just gonna kind of jump at that page and then start reading, don't let them read like 5 things and then force them to go to a different page to read another 5 things and go to a different page. Like if they're only going to be used in this one file, like put those types there, kinds of thing.
Yeah, okay, that makes sense. So let me, no, I was going to say, let me give you a hypothetical. It's not really hypothetical because I was doing this last night, or in the wee hours of the morning this morning. So I'm working on a Vapor app, and there's a part where I'm trying to like be good and okay-ish at logging things and kind of including some metadata to help debug and everything. And right now I've got like a function that takes an object and condenses down. It's a fairly large like JSON decoded object, and I just kind of condense it down into like the important stuff in a dictionary to then log out. I'm only using it in one place, so it is a single-use function. However, I guess my question is like, it's in its preliminary steps, so I know that it's going to be used later. Should I not make a single-use function until, or yeah, I guess my question is like, should I have just made the dictionary in line of that function until I needed it to be like a multi-use function? Or if you know, I don't know. You know what I mean? Like
You kind of gave the answer, right? You you're planning to use it later, which means you're doing a bit of API design right then and there, right? So
Yeah.
you know at that point that you do want to use it for multiple things, or perhaps in multiple places. So that's an excellent candidate to make into a function or an extension on something. So that way you
Okay.
can go ahead and just get the entries that you want to go ahead and log, right? But if you don't know if you want to use it later, you can kind of spin your wheels a little bit and say, hey, do I want to do it this way, or do I want to do it that way? Or you can just be super lazy about it and be like, this is a dictionary now, and that's all there is
Right.
to it, right?
Yeah. Oh, one thing I wanted to bring up as well. We were talking about single use functions. I don't know, a couple weeks ago in Slack, and Fernando and Dimitri were kind of going back and forth about this. And Dimitri kind of put forth an interest. I think it was you that put forth the interesting idea where you could make this single use function, but it's sort of in line, like a function within a function, basically, is what I'm getting at. Where that way you're sort of signifying this function is local to the sort of super function, parent function, and it's only available within that function to kind of limit
The scope.
limit that, or kind of mark it as for use within that own function only, I guess. I don't know what I'm
Yeah,
saying
so
here.
that's actually it's a super neat trick because it allows you to put some semantic meaning behind, like, here's a bunch of lines of code that are pertinent to the current algorithm but kind of unrelated. So it's just going to get like visually noisy if you're trying to read through the complicated bits. And you have like smack 10 lines of code that are not super useful at that point in time. I definitely am a big proponent of like putting that in a function at the header of your current function. Like, just put it away there. You can always command click to jump to it. But if you can name that function well, then it adds to the legibility of the code that you're about to read, right? If you don't have all that noise there. Other benefits, Xcode will indent it, like nest it within the parent function in that navigator where you see all the function and methods in your type. So that keeps that nice and clean. You can never accidentally call it from anywhere else. So there's benefits there. So I think that's like a super great way of going ahead and doing that. Another example of this that I use quite often is in SwiftUI. SwiftUI, oftentimes you end up with a giant nested structure for your body. And some circumstances, the compiler will just yell at you and be like, I don't know how to reason about this in reason one amount of time. And you're like, it's been 10 seconds. Just use another 10 seconds. You can figure it out. But the computer's like, no. So at that point, putting an inline function is a great way of like computing those like 4 operand math operation that you're like, oh, what if I divide by 2? Okay, let's add 1. Oh, and now the compiler's not happy anymore. Just put that in a little function. And oftentimes it's like so happy with you at that point. Other things I like to do is make properties for all the components of my giant body. So if I have a scroll view, I'll put a var scroll view of type some view, open curly brace, and then put all my scroll view like subtree there. And then in my VStack, I might have the scroll view, a header, and a footer. And that'll be my body. It'll be a VStack, scroll view, header, footer, and that's it. And then header, footer, and scroll view will be properties that kind of contain those subtrees. And that's another great way of kind of abstracting it away and lending legibility to your body, right? Because then at that point, you know what your body's composed of from high level.
Oh, sorry.
No, go for it.
I was just going to say that's something that I've done in admittedly the little Swift UI that I end up writing nowadays, but it's been super nice to be able to have that body property be very condensed and concise, so you're not having to literally scroll to kind of imagine the entire view, but you have that overarching, like, this is my navigation view, here's my scroll view, here are these buttons or whatever, this table or this list. It is really, really nice, and it's something that I've begun to slowly adopt in my little Swift UI code. So there's definitely, I think that's a super great use for kind of abstracting out your code.
And again, you don't need to abstract it all the way into its own view. Like you don't
Exactly.
have to
Right.
have like a one use scroll view. Like again, that's taking it too far because it's only going to be one use at that point. It's only used there, and potentially another developer might be like, "Hey, there's a scroll view. Let me just go ahead and use it." And that's like the wrong scroll view to use. That was a very specialized one that you were using only in that circumstance. And then they modify the padding on it and it breaks your screen unintentionally. So always think about it from that point of view of like how much that you want to pull away, how much you want to refactor, how much you want to kind of put some effort into designing the API that you're writing so that way you can be a more effective developer tomorrow, right? Because sure, we may not be writing frameworks all the time as like app developers, but if you practice that a little bit, then you become a better app developer because you can write your components that your app is using as if you were a framework developer, right? Like put yourself in Apple's shoes when they write Foundation or UIKit or AppKit, or SwiftUI even, see what kind of trade-offs they use for naming, for individual things, why they follow certain patterns or not, and learn from that because you can apply those things to your own work and make future you more effective at doing your job, basically.
Yeah. I think another thing with that just reminded me when you said, kind of emulate Apple in that sense is document your code because that is awesome. When you make an abstraction, you're intentionally, I think for better and for worse, hiding complexity. And so when you hide the complexity, you need to make sure that it's being used the right way. Just like Dimitri said with that scroll view example, if you maybe named it a very generic name for that object, you just say like my scroll view, well, that doesn't really tell you much about what it's actually doing if it's custom and kind of specific to one certain place in your app. So definitely document your code. I mean, SwiftUI was undocumented for a long time, but document your code. So
learn the best parts, not the worst parts.
Yes, do what I say. Do what I say, not as I do. Apple. So yeah. Anyway, that just reminded me. Like that's I think another huge thing of writing any code, but like when you're making some abstraction and intentionally covering up some bit of code, definitely make sure that it's used in the right way.
Mm-hmm. And Lynn was actually asking me like, how should I document like this property that's called like scroll view as an example? And something I was telling her was think about how it's being used and talk about that in the documentation. Say, oh, this scroll view is being used by this view over here to represent this in this way. Like that is a whole lot more information all of a sudden that is going to be really helpful if you ever need to reread that. As opposed to if you have a property called scroll view and you say the scroll view for the view. Like that is not going to necessarily help anyone, but it's a super common thing. Like we have these itches. Oh, we got to document everything. We got to test everything. And it's like the test doesn't test anything or the documentation doesn't actually add any information. You want to write it in different words, kind of like a definition. You don't want to say definition for apple. An apple. That's not going to be a useful definition, right? You need to describe what it is. Like, oh, it's a red fruit that tastes sweet. Like, what else would you want to know about it? Oh, the fragrance is like this. To make them, you have to graft the tree. It's not something that you just like plant the seed, and so on and so forth. Like, there's all sorts of information that you can add at that point. Think of it like an encyclopedia entry. Except you're the thing that invented the thing that you're describing. So what would people be interested in knowing? That's what you should document with, rather than like what it is. Because what it is...
How is it used?
Yeah, how is it used? Who is using it? What kind of behaviors does it have? What's it going to do in different situations? All of that is super useful, and that's great practice because eventually you're gonna know like, oh, this is too much information. This is not enough. If you go through that process a lot. One of my favorite kind of like lessons, like life lessons, is from doing martial arts. Generally, they say do it slow and thoughtful. Like, think about all your movement and do it slow at first. Don't do it fast. Don't try to put power behind it, because sure, you'll do it fast and you'll put power behind it, but you'll do it incorrectly. It's only by doing it slowly and thoughtfully that over time you will naturally just get faster and more powerful at it. And when you do get faster and more powerful at it, it will be done properly rather than being done sloppily, and effectively, much more effectively. This week's episode of Code Completion is brought to you by Not Pho. Tired of eating the same old meals time and time again? Consider Vietnamese food. You might already know of pho, but there are a ton of other flavors specific to Vietnamese cuisine that are sadly not well known around the world. This includes everything from sandwiches like banh mi, rice plates like com tam, and even delicious savory crepes known as banh xeo. And that's where the app Not Pho comes in. It's a free-to-try app dedicated to teaching you more about the wonders behind Vietnamese cuisine, brought to life with colorful and interactive illustrations and animations. Learn how to make many classic Vietnamese flavors at home, but even if you don't cook, you'll know how to order like a pro the next time you visit your local Vietnamese restaurant. New since version 1.1 is the Chef Club, regularly bringing you even more recipes like avocado and mango smoothies, fried rice, chicken curry, and my personal favorite, chicken beef, for the low cost of $2 a month, with more recipes added regularly. This month, the Chef Club saw the addition of shrimp and grilled pork spring rolls, which make for a perfectly refreshing snack in the late summer heat. Thanks again to Not Pho for sponsoring our show. Search for Not Pho, that's N-O-T space P-H-O on the App Store today to give it a try completely for free. So now that we've gone over our topics, it's time for Complete the Code, where we quiz our listeners on your knowledge of Swift, Apple, and all things development. Spencer?
So this week we have the same async await prompt as last week. So if you're listening to the podcast, you can check podcast art or the show notes to follow along. So it is, here we have an async method that loads a list of images one at a time from a list of IDs. How can you make all calls to load image run concurrently and return images in the same order?
So thank you, Spencer. If you think you can complete the code, tweet your answers to us with hashtag CompleteTheCode, all one word. The first to get it right will get a shout out on the following week's show. So for this week's mini review corner, I'm bringing back the Legend of Zelda Game & Watch that we talked about last week. And this time, I think we both received one, correct?
That is correct.
So how are you liking it so far?
Yeah, it's cool. I've only used it a couple times. I started playing the original Zelda, and then I said I'm not that much of a masochist, so I'm going to move on to... It's before my time, and I mean, I've tried to play it before, but I haven't quite got into it, so I'll get around to it Sunday. But I started playing the Link's Awakening, which is cool because that was one of the first games that I got for my Game Boy Color, like way back in the day when I was a kid.
Mm-hmm.
So it's
the
been
DX
fun
one.
The DX one. It's like monochrome and everything. So it's been fun to play through that. I got to the second the second dungeon boss and keep dying. So that's where I am. But it's super cool. I don't have it nearby, but it's I mean, Dimitri was talking about it last week, but some things that I noticed when I got it were it's small, but like not too small, and the screen is surprisingly a lot better than I was expecting it to be. It's really bright, and Dimitri mentioned that if you kind of angle it around, it kind of distorts the colors and stuff like
old school LCDs. I love it.
It's really cool, but it's bright and like very colorful, and I don't know, like the resolution's good. It doesn't look I mean, pixelated is not the right... It's not blurry or fuzzy or anything. It's got good sound, and there's even like a light on the back that has the Triforce logo, which is cool.
That you never notice. Like if you're playing, you don't notice that's there. Someone else pointed it out to me. I'm like, oh, that's so cool.
It's super cool, and it charges via USB-C, so that's a huge bonus as well. So super cool. It was $50. Mine, I got it from GameStop. I just ordered it like that same day that we recorded last week, and it came, I think, 4 or 5 days later or something. So super cool, super recommended. I started just for fun. I was like, I wonder if you can like mod this, and started looking into videos and like seeing if you could load other ROMs and stuff on it, and you can, but it's a fairly involved process, it sounds like, where you have to, of course you have to take it apart, but you have to start soldering things. And I was like, I'm good. I'm not going to do that. My soldering skills are not great. So, but it is super fun and would highly recommend. I'm thinking about getting the Mario one just to kind of have more than play. I don't know. Mm-hmm. The box is cool because you can kind of, there are a couple tabs that you can pull out and turn it into a stand and stuff. So if you just want it as sort of like to put on a shelf, you could do
like a clock with the clock little game that it has.
Yeah, but I think my thing with the clock was it has that annoying ticking, and I couldn't find out how to turn it off. And I hate ticking clocks. That's like a huge pet peeve of mine.
So if you press the pause button, then you can change the volume. I realized this after people are telling me that thing is getting super annoying. Because I played a whole lot of The Legend of Zelda, the original one. And like you, I approached it with like, oh, this is like way too hard and before my time. But the more I played it, the more I realized that it's actually quite approachable in that you can visualize in your head like the whole map, the whole overworld. It's not so big that you can't remember it over like playing it for a few hours. And you do start to remember where stuff is, and you do start to get a little lost, and it's on purpose because they are purposefully making you lost in those areas. You do learn how to combat certain enemies and not die repeatedly. You do learn that you can just grind your way through and keep trying. And then buy a magic amulet that is way too expensive. And then you stop dying as much anymore. And that's awesome. So you really do go through like the waves of emotion as you discover new things and level up your character. It's not like everything... it always felt like, oh, everything is behind this obscure boulder and you're never going to get to it. And the old man is going to be totally useless. So, like, while I was playing, the hints that the old man gave, I was like, oh, I visited a place that was kind of like that. The only places that are, like, so, like, obscure, it's because that it's, like, an extra little thing that is not super necessary to, like, make progress in the story. But you will come across dungeons on your own. I came across level 3 and try to get through it as much as I can and just could not with 3 hearts and no amulet or whatever. But then I found level 1 and I was like, oh, this is actually super easy compared to level 3.
Right.
And then I had 4 hearts and then I couldn't find level 2 forever. So I went to level 3. I beat that one. Got to level 5. Struggled a ton with the dark nuts, but eventually realize that if I go to level 4, if I can find level 4, then you get the little raft, and then immediately you have access to like 3 hearts out in the overworld. So like it really does open itself up, and it's not as bad once you get into the rhythm of understanding how to control the damn thing and not have cramps in your hands because it's really tiny.
Yeah, that's true.
But you do get better at it. Like it's awkward at first, like you don't react the way you want to react, but then little by little you do get better, you do improve, and that's something I wasn't expecting but was very happy with, and it makes a game like that hold up kind of well when you do spend the small amount of time that it needs from you to be able to continue and actually work.
That's fair. I'll give it a shot. Maybe once I finish Link's Awakening. Yeah, I've thought about like, I haven't done it. I should look. I'm sure someone's made one, but trying to find I guess a grip to 3D print so I can not have hand cramps. It's not bad, but you kind of have to like weirdly tiny. Claw grip it. Yeah. So it's cool.
And you need to react quickly. Like if you're not holding it right, the thing will slip and you're gonna die. You will die very quickly.
That said, don't let it deter you because it's super fun. It really is a cool device. So I'm super happy with it. And I think you definitely get your money's worth. Just, 3 games people I think were probably not super happy with just only having 3 games. But realistically, like
it's a fun little toy. Like,
yeah,
ultimately.
It's not bad. Yeah,
it plays well. You don't see pixels because the pixels are super tiny. and you have fun playing the original games.
Yep.
So, as always, I want to personally thank everyone for listening in this week. Please be sure to follow us on Twitter at CodeCompletion to know when new episodes get released, and feel free to tweet at us if there's ever a topic you'd like for us to dig into. Most importantly, as a small podcast, please be sure to share this with your friends and family who are interested in any part of the process of app development. It's your support that enables us to continue doing this, and we hope to grow a healthy community around everything we discuss. Once again, I want to give my thanks to Spencer, who's at Spencer C. Curtis. That's SpencerCurtis on Twitter, for joining me this week. My name once again is Dimitri. You can find me at Dimitri Buñol. That's DimitRiBouniol, and we'll see you all next week.
Bye.
Bye.